Dear students, today actually we are going to discuss the concept of velocity. Okay, it will be the third concept we are going to discuss from the topic from the chapter kinematics. Okay, especially we are focusing on motion in one dimension, and today's concept will be velocity only. Concept number 3. So, as you know, I am Mr. Amarnath, and let us discuss it. Okay, first let us understand what is velocity. Okay, and I have already told you speed is what, distance by time. Okay, so velocity. So as we have already discussed what is displacement, what is distance. Okay, so in the last class we have discussed distance upon time is speed. Okay, but today we are going to discuss velocity, so it will be nothing but rate of change of displacement only. Okay, the rate of change of displacement is called velocity. Okay, as displacement is a vector quantity, so obviously velocity also will be a vector quantity only. So you please keep on noting all these things in your data fair copy. So let us take the similar example only. Okay, say this is a zigzag path. I need to go from point number A to say the other end of B. Okay, so the path is a zigzag one only. But if I take any small segment in between, okay, so this is the segment. Remember, in this segment also, I am going to get a small displacement. So that is say given by the arrow. Okay, that is a ds vector. So ds, to cover the ds displacement, I need some dt time. Okay, that ratio ds by dt, that ratio is called instantaneous velocity. Means velocity at that moment. Okay, it is almost similar to that instantaneous speed, but in speed we take only the magnitude of that displacement, which is distance, but here I have to take the actually displacement. Okay, so it is nothing but v velocity equal to rate of change of displacement, or we can say the differentiation of displacement with respect to time. Okay, so this is the first formula you are getting. We have to have lot of numericals on it. Okay, so I am keeping it in box. And what does it mean? It is nothing but a slope of the st graph. Already we have discussed now. So it is nothing but displacement versus time graphs slope. Okay, so velocity is nothing but displacement versus time graphs slope. Well, say something like this, say graph is given. Okay, something like this, say graph is like this. Okay, this is displacement, this is time. Okay, so I need to calculate the velocity at this point. So what I do, I just calculate the slope at this point only. Okay, nothing else. This theta, so tan theta, tan theta. At this point, what will be the tan theta? Okay, like this. So that is also important. Yeah. Okay, velocity equal to slope of st graph. Please note it down. This one. Let me know once it is copied properly. Okay, v equal to differentiation of displacement with respect to time. V equal to slope of st graph. These all formulae will be used for calculations. Then what I can write, you see, v equal to ds upon dt. So ds equal to what? V into dt. I can write like this also, na? Just crisscross only. Okay, ds equal to v into dt. ds means what? That is small displacement. Okay, ds is what? That is small displacement. So v is what? Velocity at that moment, and dt is time. So velocity into dt is nothing but displacement at that. Okay, so if I need to calculate the total displacement, say from here to here, I need to calculate the total displacement. So total displacement is the shortest distance only, na, this line. So what I do, I just integrate it. Okay, integration of ds is what? Integration of ds will be just s only. Okay, so this is also another formula. Okay, that will be used in numericals. Means if you are given velocity as a function of time, just you integrate, you are going to get the total displacement. I repeat, total displacement. Integration of velocity gives you total displacement. Integration of speed gives you total distance. Okay, what we had discussed in the last class. So let us keep it also in box. Okay, this is very important. And you already understand that integration is nothing but the area under the graph. Okay, say this is v versus t graph. Okay, so say graph is like this. So integration of v dt means area under this graph. Okay, just geometrical meaning of integration is this only, nothing else. So that is why what I put, total displacement is nothing but area under, it will be velocity time graph. Okay, total displacement equal to this one. Okay, that is also important, which is we are going to use it for numerical. Okay, we have already got 1, 2, 3, 4 formulae. Okay, you have already got today itself, you got 4 formula. V equal to ds by dt, first formula. B equal to tan theta, or it is slope. This is also called slope. Second formula. Okay. Then, and last one is what? That area under VT graph. Okay. S equal to area under VT graph. So can I rub all these things? Just let me know if you have copied it. Okay.
Yes, sir, done.
See, first example. The position of a particle, moving particle along x-axis varies with time as this. Okay, find the velocity of the particle at t equal to 1 second. Remember, t equal to 1 second means at that instant I need to calculate. So it is instantaneous velocity. Okay, we want. So it is also clear in the picture that because time never comes back and time never stops. Okay, time always keep flowing. It means t always increase. So as t increases, so x will also change. If it is changing, it means the particle is in motion. Okay. So I need to calculate the velocity. We know instantaneous velocity at this instant I want. We know v equal to ds by dt, but now they are going along x-axis, so I am putting dx by dt. Okay, same thing. So that is nothing but ddt of, if it goes along y-axis, so I will put dy by dt, along z-axis d z by dt, nothing else. So in case of x, I am putting this one. Okay, so it is nothing but 5. So these terms, these steps you can jump also if you feel comfortable. So you can easily jump. That t square it is nothing but 10 into t, and it will be t only. Okay. So please keep on checking the calculation part. Remember, it is becoming velocity as a function of time. Okay. At different time, I can find the velocity. But you are asked to calculate at t equal to 1 second. So it will be what? 10 into 1 plus 2. It is simply exactly similar to that one only. 10 into 1 is 12, na? 12 meter per second. And one more thing, you understand that as the particle is traveling along x-axis only, okay? As it is traveling along x-axis only, it is not coming back. Okay, you see, for any value of t, x will keep on increasing only. X will not decrease. Yeah, x will not be negative. It means it is a unidirectional motion. So it means distance and displacement also will be same only. Okay, so if I ask you the velocity, instead of velocity, they are asking about speed. Then also answer is same only, because they are going in the same direction. Na? The answer will be same. Okay. So I hope you understand. It is not a big deal, I think. Na? Already similar questions we have discussed. So I am going to give you another question of similar type. Okay. So let me also try. Okay. So again, I know that it is v equal to what? Dy upon dt only. So it is nothing but ddt of t cube plus t only. So differentiation of t cube is, it is nothing but 3t square, and it is 1 only. Okay. So that is the v expression. And at t equal to 3 second, v will be 3 into 3 square plus 1. 3 to the 9, 27 plus 1. Yes. So it will be 28 only, okay? So I think I should better change the flavor of my question, okay? So I'm going to discuss one different type of question, okay? Remember now going to the reverse journey. The velocity of a particle moving along a straight line varies with time as v equal to 3t cube plus 2. Find the displacement it traveled in first 2 seconds, okay? Remember, earlier I was given displacement, I calculated velocity, but this time velocity given, but I need to calculate displacement. Okay. So how should I proceed? I know that v equal to what? V equal to ds by dt. So it is vector, I can put vector, no issue. So that is displacement, that will be equal to v into dt. So if I need to calculate the total displacement as it is said in the question, okay? It is v dt from 0 to 2 seconds, 0 to 2 seconds. When time was 0, so displacement was 0. When time is 2, so displacement will be s, okay? So in the left side, it will be s only, s minus 0 is s. It will be 3t square plus 2 into dt, okay? 0 to 2. Here also you can find as a function of time. Huh? I suggest actually first you calculate as a function of time only. And finally, you will put the value of t as 2, okay? So it will be better. So s will be what? T into integration of t square dt. So what is the integration of t square dt? You know. It will be integration of 2 dt. It is similar that last yesterday's class. Okay, what will be the difference? And you will be understanding after 2 or 3 more examples. So it will be what? T cube by 3, I think. Na? Yeah, t to the power 2 plus 1 by 2 plus 1. Yes. It will be 2t. This cut.
Sir, in question it's 3t cube, sir.
Achha, in the question it is t cube. Okay, okay. Sorry. So in the question it was actually 3t cube plus 2. 3t cube plus 2. So it will be t to the power 4 by 4. So we cannot cut it now. So answer is 3 by 4 t to the power 4 plus 2t. Okay. So this is the expression of displacement as a function of time. If you differentiate it, again you are going to get this only. Okay, nothing else. You can check also, cross verify also. But now they are asking for the first 2 seconds. Na? So at t equal to 2, s equal to t by 4 into 2 to the power 4, 2 into 2. So it will be 2 to the power 4 16, 16, 4, 12. This will be 12, 2 to the 4. So s is equal, I think, 16 meter. Okay. Yes. I'm going to give you another question, exactly similar. And in that case, you please try to answer it as fast as possible. Then again, I'll change the flavor of the question. Okay, I'll change little bit uh, differently. I will try to solve. The velocity of a particle moving in straight line varies with time as this. Okay, similar question. So you can work on your speed also, because you see in examination now, speed and accuracy both are very important. Now, so what I do here, s is equal integration of v dt, integration of 2t plus 1 dt from 0 to 2. So that is 2 times t dt plus dt 0 to 2. Directly I am putting, okay? So it will be what? 0 to 2, then 2 times t square by 2. 2 cut. That will be 2. 0 to 2. So 2 square is 4. Answer is 6. Exactly, okay? All of you are correct. So, without losing any time, I am going to the next question. And next question is a uh, almost similar, but still there is some tricks. Okay, if you can catch it, it is 90. I am giving you some time. Okay, so let us discuss the next question. Okay, now you please try these questions. The velocity of a particle moving in straight line varies with time as v is equal 2t minus 4 meter per second. It should be. And find the displacement when velocity changes direction. Okay. Here actually you see we are given that v equal to 2t minus 4. Okay. Now you see, if t is greater than 2, okay, if the time is greater than 2, then v will be positive, okay. If t is greater than 2, v will be positive. It means what? After 2 seconds, velocity of the particle will be along the positive x-axis. But if t is less than 2, then v will be negative. V will be negative. You can put the value, see. This is 2, okay, 2 to the 4. But if it is more than 2, this part will be more than 4. It means V will be positive, okay. Similarly, for less than also we can discuss. Na? So it means at t equal to less than 2, the direction of velocity is negative, okay. So what does it mean? As the time starts from 0 only, na? So as the time goes, first the particle goes in that one negative direction. Then at time t2, t equal to 2, it started moving towards the right direction, okay. So it means at t equal to 0, it is changing the direction, okay. If you ask me, sir, how did you know that it is 2 only, okay? How it comes to my mind? So it is very simple. In such cases, when a particle changes direction, at that moment, velocity will be obviously 0, okay? Say one particle is thrown vertically upward, its velocity goes on decreasing at the highest point, it becomes 0, then it comes back, So it is similar to like that only, okay? So make V 0, okay? Because when velocity changes direction, at that moment V becomes 0. So it means 2t minus 4 becomes 0. So that t will be what? 2. So t is the crucial time, okay? So now you start writing this. If t is greater than 2, V equal to plus positive, and if t is less than 2, V will be negative, okay? So now you see, we are asked to calculate the displacement till the velocity changes direction, okay? So as we know that displacement equal to what? Integration of v dt only. So it is nothing but 2t minus 4 dt only, but the integration limit will be from 0 to 2 only, okay? Because we need to calculate the displacement from here to here only, okay? This much only. So I think rest of the integration can easily be done. So it will be 2t dt minus 4 integration of dt. So it will be 2 t square by 2 minus 4t cut. So ultimately displacement will be what? Ultimately displacement will be t square minus 4t. But you have to put the value of 2. So it means this will be nothing but 2 square minus 4 into 2. So answer is minus 4, okay? 2 to the 4, 4 to the 8. And it has sense also. You see, as we have already analytically discussed that from t equal to 0, the particle started traveling in negative direction. Na? So obviously displacement will be negative only. Okay, it has some sense. So as it goes to -4 and t becomes 2 and it started moving again in the positive direction. Okay, so this is the story of the that one motion. Okay, how the particle moves. Did you understand all these things?
Yes, sir.
Okay, please try this. The velocity of a particle is v equal to 8 minus 2t meter. Okay, find the displacement when velocity changes direction. 2 minutes for you. After this question, we are going to change the flavor again. Okay, we'll do some graph questions. Okay, questions from graph.
So answer
Sir.
is 60 meter.
Let me check it. I also exactly don't know. I have to solve it.
So I'm getting the T as 4, sir.
Okay, both of you please use the chat box, write it so that I can also uh, understand, okay, what you have found. So if I discuss, see similar way, uh, here actually V is equal 8 minus 2t. So if you took V equal to 0, so because when velocity changes na direction, so that point V becomes 0 only, okay. So here 8 equal to 2t, it means t equal to 4 only, okay. That 4 second is the crucial time, okay. Now you see, if t is less than 4, so you see, if t is 4, then it becomes 8, so 8 minus 8 is 0. But if t is less than 4, if t is less than 4, it means 8 is bigger than 2 into t. No? So it will be, the whole quantity will be positive only. So it means when t is less than 4, the v is positive. It means the particle is going initially in positive direction. Okay. So at t equal to 4, from t equal to 0 to t equal to 4, the particle is going in positive direction. Okay. At t equal to 4, it is changing direction. If t is greater than 4, so this part will be more than 8. So it means v will be negative, na? So v is negative. So it means it will come back. But I want to calculate the displacement till the velocity changes. It means 0 to 4. Okay, limit will be 0 to 4. Therefore, displacement is, we know that it is integration of v dt only. Remember, yes, of displacement, okay? So it will be v only, okay? I'm not putting the arrow mark everywhere, but it is understood, okay? We are discussing only velocity. Sorry. So what I do here, it is 8 minus 2t into dt. So it is 8 dt minus 2 t dt. So it is becoming 8t minus t square, I think, okay? Because t square by 2 and t cancel. So if we put the limit actually 0 to 4, no? So it will be what? 8 into 4 minus 0. And this is 4 square minus 0 square, okay? So it is nothing but 32 minus 16. So I think it is 16, na? And it has sense also, I think, the positive value. Okay. So now let us change the flavor. Huh? Remember, slope of displacement versus time graph give you velocity. An area under velocity time graph gives you displacement. Okay, we have already discussed the theory. So we are going to that one actually solve some questions based on this only. Okay, graph only. Let me draw a graph, and you also simultaneously draw the graph with me only. Okay. So say this is time axis, okay, starting from 0. Well, means x-axis is nothing but a time axis, and the y-axis I am say taking as the displacement, okay, this time, because graph is velocity, na? So it must be displacement, okay. So let us draw the graph, okay, arbitrary graph I am taking, okay, nothing else. You can also do your way. Say this is graph is to some extent like this, okay, and give the coordinate also. Say this is 3. This is say 2, okay? Say this point is say 4, this point say 8, this is say 6, okay? So what is my question? I'll ask you the velocity at different points, okay? To some extent same as that and speed only, but what is the difference here you will understand, okay? Step by step. So first, okay, this point's coordinate also -4, okay? So you see the displacement in meter traveled by a particle varies with time as shown in the graph. Find the velocity at t equal to 1 second, okay? Find the velocity. But remember, this time actually if velocity is positive, you should better write positive plus. If it is negative, you should write negative, okay? If you don't write positive also, then also okay, okay? But if it is negative, you must put negative because velocity is vector. But in the previous case, speed never be negative, okay? So one point is here only, na? This is one. So at this point, actually, I need the slope. As it is a straight line, slope will be same, okay? So it will be nothing but perpendicular by base, okay? Because the slope here, slope here, slope here, everywhere it will be same only. So what is the perpendicular? Perpendicular is, so velocity is nothing but a slope. Perpendicular is, I think, 3 minus 0 and base is 2 minus 0, okay? So answer is 3 by 2 meter per second, okay? So almost similar question, we have already done it. So please try the second part, okay? Let me give one more part. See, what will be the velocity at 3 seconds? Please try to try it. Velocity at 3 seconds.
Sir, but I have a doubt that you have calculated at 2 seconds, but the time is like only 1 second.
No, you see, this is actually the velocity this velocity is not only at 1 second, it is at 0.5 second also, it is at 1 second also, it is at 1.5 second also. It means it is anywhere in between 0, because graph is like this, okay? It is a straight line, okay? The slope here, slope here, everywhere it will be same only, na? So what I am taking
Yes,
a
sir.
bigger slope because I know this data. I know this data, okay? Because I know this code
Yes.
is 3, okay? 3. And I know this also it is 2. So that is 3 minus 0. 3 minus 0, okay? This is the perpendicular. And 2 minus 0, it is the base. So if I take this one also, the answer will be same only. If I take this perpendicular, okay? So this perpendicular, this is 1, this is 0. So I know the base, but I don't know the perpendicular. Now you see, I don't know this. Again, I have to calculate this coordinate of this point now using some similar triangle concept. Okay. So who will go for this complicated process? As it is a straight line, the slope will be everywhere same. It means velocity at this point, velocity at this point, velocity at this, everywhere it will be same. Okay? Understood, na?
Got it. Yes,
Okay,
got it.
okay. If I calculate this slope, I need to know this point's coordinate. Okay. Anyway, so please try the second part. So what will be the velocity at t equal to 3 seconds? So try to find out the point 3 seconds. Where it is? 3 second. It is here, okay? Somewhere. Again, it is a straight line. So the slope here, it is also zero slope. This is also zero slope. This is also zero slope. So everywhere slope is zero only. So velocity will be zero simply. But if you want to calculate using that perpendicular by base concept, okay, that way also you are going to get zero only. How you see? Velocity equal to, see, this is 3. This point's S coordinate is 3. This point's S coordinate is also 3 only, okay? And this point's time coordinate is 4. This point's time coordinate is 2 only. So 0 by 2, it is nothing but 0 only, okay? But again, you understand that when the slope is horizontal, when the graph is horizontal, the slope is 0. When the graph is vertical, slope is infinity. When the graph is at some 45-degree angle, the graph slope is 1, tan phi is 1. We are going to actually calculating tan theta only, tan theta, which is nothing but perpendicular by base, okay? Perpendicular by base. So if the perpendicular is 0, it means this graph will be not like this. This graph will be just lying horizontal only, na? Perpendicular part will be 0, na? As you keep on decreasing this length, this graph will fall down, and finally it becomes horizontal. Did you understand, guys? Did you
Yes,
understand?
sir.
Okay.
Yes,
Then just try this part, okay? Actually, from here, the slope becomes negative only, okay? Here positive slope, here zero slope, and from here onwards, even the velocity at this point also will be negative, this point also negative, this point also negative, here also negative, okay? Because it is a negative slope only. 7 point is somewhere here, okay? So it means you see, the slope, it is a straight line, so slope everywhere will be same only. So what you do? Nothing but perpendicular by base, okay? So velocity at 7, it will be equal to what? Perpendicular by base. Perpendicular, this one perpendicular, no? So it is final minus initial always, no? So this is also final minus initial. So 8 minus 6. So automatically also you are going to get negative only, okay? It will be, I think, minus 2, no? Minus 4. 8 minus 6 is 2. Oh, yeah. Meter
Sir,
per
I
second.
have a doubt that where did 4 come from? -4.
Pardon?
I'm asking, sir, that where did -4 come from?
Where from this minus 4 comes, na?
Yes,
You
sir.
see, actually this is nothing but the perpendicular, okay? Perpendicular. In this triangle, this is perpendicular, this is base, na?
Yes,
Okay,
sir.
slope is this only. So perpendicular by base I am calculating, okay? And this is actually always final position minus initial position, okay? Here also you can see I have written 3 minus 0, okay? At this point,
Yes,
you
sir.
see, at this point, think of this point, huh? Think of this point, think of this point. So this is initial position, this is final, okay? As
Yes,
the
sir.
time is increases, so it means this is initial, this is final for this package, okay? So it means final coordinate is 3, initial coordinate is 0. Final time is 2, initial time is 0. So exactly that way,
Yes, sir.
for this package, 8 is the final time, 6 is the initial time. So it is 8 minus 6, not 6 minus 8, okay? So exactly that way, when it was 8, the position is minus 4. So minus 4 is the final position. And this is 0. Because you see, na, S is 0 here. That 6 is the time coordinate only, na? But S coordinate
Yes,
is
I
0.
got it now.
So that is a
I got it now.
final minus initial, okay? Take another similar graph. This time actually VT graph I am drawing, okay? VT graph. So same graph is to some extent same only, okay? Okay, okay. Now the question is what? The velocity in meter per second of a particle varies with time in shown in the figure. Find the displacement travel between t equal to 0 and t equal to 4. Okay. Remember, displacement equal to integration of v dt. Displacement equal to integration of v dt. And it is also called area under v versus t graph. So that is the theory. The geometrical meaning of integration is nothing but area. Okay, just you need to understand it. If you do not write this, okay, you just write this part only, because area under the VT graph means integration of VT only. Okay, you have to doubt. I can explain once more. No need to worry. But here, as already graph is given, so you need to calculate only the area under the graph. Under the graph. Here actually 0 to 4, na? 0 to 4. This is 0 and this is 4. So it means I need to calculate this much area under the graph. This much area. This area only I need to calculate. So do you know what is this? How to calculate this area? We are going to calculate it using a separate triangle or a rectangle and one rectangle, or you can want to calculate simply by taking it as a trapezium, because it is trapezium only, no, nothing else. Both way you can do, but you are going to get the same answer only. Okay, no need to worry about it. But whatever procedure you apply, but answer should be same only. Okay. I'm using it I'm using this. I'm solving this, taking it as a trapezium. Trapezium area is what? Half into
Sum of the parallel sides into
on the
height.
parallel side. You see, parallel side is what? Parallel side. See, here the length of the side is 2, and here the length of the side is 4. Okay, so it will be 2 plus 4. Okay, okay. I accept your answer. Okay. Into separation between the two sides, no? So it means separation is this. Okay, this is nothing but 3 only. So this will be 3. So answer is what? 6, 3, 9, 9, 9. 9 meter is the answer. Okay. With that concept, please try this question also. Your time starts from 2 to 4 seconds. Achha, remember, one more thing, 2 to 7 seconds. One more thing. Upper half area is positive, lower half area is negative. Remember, this half area will be negative only, okay? The area is a vector quantity. This is negative. upper half says that particle is going in this direction. Lower half says that it is coming back in this direction. Okay. So that way you have to calculate. Please try it. So what I do to calculate the displacement between t equal to 2 and t equal to 7. Okay. From this point to this point. Okay. So it means I need
Sir,
to.
can we break it into two steps?
Pardon.
Can we break it and do it from 2 to 6 and then
This
from
is
6 to
also, I think,
7?
I think this is second triangle. Okay, it will be a negative area, and that is trapezium. It will be positive area. Okay, so if I do it, so I think I'll do it this way. You see, the total displacement is nothing but first area minus second area. Okay, so first area is nothing but half into sum of the parallel sides. Na? So here to here. It will be again 2 only, okay? 4 minus 2 is 2 only. And here to here, 2 to 6, it will be 4. And the perpendicular distance is 3, no? 3, okay? So this part is area 1. Minus area 2 is half into base into altitude, nothing else. Base is 1, okay? This is 7 minus 6. And this is 3 only, okay? Remember, you don't put minus 3 here because already you have taken minus here. Na? Actually, this is the minus only, okay? If you put plus, here you have to put minus 3. Na? So automatically, don't put the negative twice. Na? Otherwise, it will become again positive like quantity only. Na? So it
Sir,
will.
I'm getting 7.5.
Okay. It is the answer is 7.5. I hope everybody is correct, okay? Because all are getting same only. So I have not done the calculation part, okay? So good, great going, okay? Now calculate distance between t equal to 2 and t equal to 7. Calculate distance between t equal to, this is displacement, okay? But if I calculate if I ask to calculate distance, then what will be the change?
Sir, differentiation.
Huh?
We have to add the area of trapezium and the area of triangle.
Yes. Excellent. Then the answer will be just plus only, okay? And what it will be? It will be 6, 2, 3, 9, and 9 plus 1.5, na? So 10.5
Sir, it
will
will
be
be
the distance. Is it?
10.5.
Everybody understood, na? No problem, na, beta? Everybody understood, na? Because
Yes, sir.
because they are going 9 rightward, then coming back 1.5, okay? 9 meter forward, 1.5 meter backward, okay? So displacement is this much, which is 7.5. But distance is this much, here to here. So it will be equal to, I think, 10.5, okay? Excellent. We need to find out the displacement between t equal to 0 and t equal to 5. So t equal to 0 is this. T equal to 5. 5 is somewhere here, okay? So it means I need to calculate area of this portion, okay? Up to this. But I don't know how to calculate it. You can do two things, okay? You can calculate the total trapezium's area, okay? Then subtract this small triangle, okay? You can do that thing. I think it will be best. What do you think? Because somehow I need to calculate the area of the given figure, okay? The figure is up to this
Yes,
only.
sir.
Otherwise, you see, you should know the coordinate of this point also, na? This point. You can calculate even this point's coordinate also, so no need in the two triangle. Now you see this triangle, the bigger triangle and the smaller triangle, they are similar. No? So from that we can easily find out that coordinate of that say perpendicular is 3 by this is nothing but 2. Okay. So now the perpendicular I don't know. Say this is y and this is 1 only because this is 5 na? So 1. So from that also we can calculate that it is y equal to 3 by 2 only. Means this point's coordinate is 3 by 2. Okay. So if you want to calculate the area by that way also you can calculate because this will becoming a trapezium and this will become a rectangle and this will become a triangle. Okay. This 3 figures area you can calculate. But I think it will be best if you calculate the total area minus the small triangle. Be clever now. We should be clever also like that. No? Somehow we have to get the answer. No? But without doing wrong. Okay. So what will be the total area? Half into sum of the parallel side. Okay. This will be 2. And these will be 6, okay, into height is 3 only, okay, minus that small triangle. Okay, for that again you need to know 3 by 2 only. Remember, that 3 by 2 part will be now also required, okay. So half into base into altitude. Altitude is 3 by 2. But 3 by 2 will be calculated from this similar triangle concept only. Okay. Whether you understood or not, but this part is very important. Huh? Otherwise, you cannot proceed actually. This point's coordinate, you know, it is
So
3.
how did we get 3 by 2?
See, this point's coordinate is 3. Okay. This is 3. This is 0. But this point's coordinate you don't know. Na? Say this is y. And this part, this is total is 2. Because 6 minus 4 and this is 1 only. This is 1 because 6 minus 5. No? So as the two triangles are similar, so perpendicular by base. Perpendicular by perpendicular equal to base by base. So, yeah, perpendicular by base equal to perpendicular by base. Okay. Both will be tan theta only, na? Same theta. This is perpendicular, okay? This is base. Big perpendicular, big base. Small perpendicular, small base. These are some properties of similar triangles, na? If they are similar, we can do like that, okay? Yeah, corresponding sides. 3 by y must be equal to 2 by 1. So it means y equal to 3 by 2 only. Okay. So it will be required, huh? Then only we can solve it. Anyway, so what will be the answer? 6 2s are 8, 4, 12. Calculation part, you please help me. Huh? 3 by 4. So 48 minus 3. 45 by 4 is the total displacement. Okay. Now, actually, we are going to discuss the concept average velocity. Okay. Remember, till now we are discussing only the instantaneous velocity. Okay. Instantaneous velocity. We have that one used the calculus method. We have used the graphical method. Na? All these things. But let us discuss what is average velocity. Okay. Average velocity means total displacement by total time. Yeah. Okay. It is nothing but total displacement by total time. Average speed means total distance by total time. Okay. So please write down the, actually say this is the a zigzag path. Okay. From A to B, I am going. Okay. So you know the, what is the total displacement? It is nothing but the joining between A and, okay. It is the line segment joining between A and B only. So average velocity will be that total displacement by total time. Please write down. average velocity is total displacement by total time. On that, actually, with that, using that formula, we have to solve some problem also, okay? So you please keep it in box also, very important. Now you see, we know that total displacement is integration of v dt. Okay, and total time is nothing but integration of dt only. So this also can be a new formula for us, okay? If the velocity is given as a function of time, so I'll integrate it within a given time interval and divide it by the same time interval, okay? I'm going to get the total displacement by total time, which is equal to average velocity, okay? In a given time frame. Instantaneous means at some moment. Well, so both are very important. Now you see, say I have covered a displacement in few steps, okay? Say initially I have covered this much distance in t1 time and that this much distance in say t2 time, okay? And some another distance, okay? Or you can say displacement also, no need to worry, because unidirectional motion, distance and displacement same, okay? So in t3 time, okay? And say I have covered the S1 displacement, okay, in the first case, and with velocity V1, okay, I have covered that one, okay, first displacement with velocity V1, and the second part displacement is say S2, and I have covered it with say V2. Well, and similarly, say third part's displacement is S3, and I have covered with velocity V3. Okay, it means I have covered all different segments with different velocity. Well, so what will be the total that average velocity in this case? Okay, let us calculate it. You see, we know that average velocity is nothing but what? Total displacement by total time. So S1 plus S2 plus S3, that is the total displacement. If it is so on, okay, it will be like this only, plus and so, divided by total time, T1 plus T2 plus T3 and so on, okay? All these things. So this is simply the definition only, nothing else, okay? If there are 3 steps, if there are 4 steps, so I have to write 4 times. Now you see that S1 can be written as V1 into T1 also, no? Because distance equal to V into T. S1 can be written as V1 T1. S2 can be written as V2 T2. S3 can be written as V3 T3 like this, okay? So if displacement is not given, if velocity is given only, different segments velocity is given, so we can use this, okay? So on this formula, actually we can that one using this formulas, actually we can solve some questions, okay? So get ready for the numerical only, okay? Well, please try to find solve this question, okay? A person is traveling on a straight line, moves with a uniform velocity v1 for some time, and with velocity v2 for the next equal time. The average velocity v is given by. So out of the 4, 1, 2, 3, 4, which option will be the most accurate option, okay? See, what is the approach? First of all, traveling in a straight line, okay? Say this is the straight line, okay? Say up to this position, it is going with, say total time is 2t, okay? Then for the first time interval t, it is going with velocity v1. And for the second interval also time is t only, because equal interval, na? So velocity is v2, okay? So, but the definition is what? Average velocity definition is displacement 1 plus displacement 2 by time 1 by time 2, okay? Time 1 plus time 2, okay? This is definition. You have to go with the definition. So that T1 and T2, that is nothing but T and T only. But S is not given. We are given only the V. Na? So that S1 can be written as V1 into T. And S2 can be written as V into T. Because distance equal to speed into time. Na? So velocity average will be what? Here it is 2t, and here it is v1 plus v2 whole into t. Okay, t will get cancelled. So velocity average will be what? v1 plus v2 by 2. See, this is like equivalent resistance, equivalent capacitance, or you can say that it is equivalent velocity. Okay. Say 50% time it is going with velocity 6. 50% time it is going with velocity 3. So what will be the equivalent velocity? It means 6 plus 3 by 2, 4.5. It means if it continually go with 4.5, then it will take the destination with the same time only, okay? As it was taken going through two different velocities, okay? Going with two different velocities. Means at the same moment, they will reach the same destination, okay? This is equivalent velocity, you can say. Means you can replace 6 and 3 with 4.5, no? 6 plus 3 by 2. Okay, v1 plus v2 by 2. Have you understood? I'm going to give you a similar question, nah? But with slightly, concept is same, but question is slightly different, okay? Please try to solve it. Slightly difference. Okay. Say this is the first stage S1, this is the second stage S2, time taken T1, time taken T2. So it means average velocity is what? By definition, S1 by S2, T1 plus T2. Okay, sorry, S1 plus S2 by T1 plus T2. So now actually given that distance is same, so S plus S and T1 can be written as S by V1, it can be written as S by V2. Okay, V average is. So it means V average is equal to, this is 2S. If I take S common, so 1 by V1 plus 1 by V2. So S has got cancelled. So it means 2 by V average equal to 1 by V1 plus 1 by V2. Okay. So it means this is correct. Okay. And you should remember this also. Okay. V average is 2 V1 V2 by V1 plus V2 also. Okay. This formula also you please remember. Okay. From that only it is coming. Now take the LCM V1 V2. Little bit interesting. Read it properly, try to understand. If you don't understand the situation, I'll explain, no need to worry. But first you give that a try. Okay, let me discuss. Actually, time is also running out. So let me discuss it. See, if the situation is half the time, then average becomes V1 plus V2 by 2. Already we have discussed. You remember? If the situation is half the distance, the average velocity becomes, we have already derived it. No need to derive it again, okay? The average velocity becomes 2 V1 plus V2, no? Two V1 V2 by V1 plus V2. Remember it. Now come to our situation. Here it is total distance. Say this is half the distance. So this is also half the distance. In this part, it goes with V1. But in this part, it goes with V2 and V3. But I took, it is average, okay? V2 plus V3 by 2. Because they were half the time, na? So when it becomes half the time, it becomes V2 plus V3 by 2. Already we have understood. So means it becomes an equivalent number, okay? Now the situation is, you see, half the distance with V1 and rest half the distance with this quantity, V2 plus V3 by 2. So what will be the average? It will be 2 times V1 into V2. V2 means second part. So V2 plus V3 by 2 divided by V1 plus V2 means V2 plus V3 by 2. Okay. So now you have to simplify it. It is nothing but V1, V2 plus V3 divided by 2V1 plus V2 plus V3 and divided by 2. So that 2 will be coming up above. So ultimately the answer will be what? Answer will be 2 times V1, V2 plus V3 by 2V1 plus V2 plus V3. This will be the final answer actually, okay? So on that note, today I'm going to wind up the today's class, okay? Okay, thank you guys. Bye-bye.